Got it. Hello, assalamu alaikum. Today we will discuss about the latest Codeforces round 891 type trace all for problem from A to T. So before I start the discussion, I am thinking that all of you read the problem statement very clearly from your own responsibility. I try to just start the main graphic view of the every problem. What is our first problem? A, array coloring. So what is the main graphic view of this problem? Here the main graphic view of this problem is we have an array A of length n. That means we have an array A where we have total n number of elements. We have to divide the total n lengths into two pitches. We have to divide this n length into two pitches such that the summation, all the number summation of the first pieces parity, and the all the numbered summation of the second, all the numbered summation of the second parity will be equal, and both parity have at least one element, and with these two parity or with these two portion, the total n length have to be fulfilled. Suppose we have an array A of length n, and in the first portion of our divided array, first portion of our divided array's length is m, and the second portion's divided length is x, and we have to create it such a situation so that m plus x is equal to n. Here both m and x must follow this condition, greater than or is equal to 1, and these portions parity. What is the parity? This is detect that the total summation of the numbers is even or odd or not. If this parity of the first portion is even, then to satisfy our condition, the parity of the second portion must have to be even. This is same for odd. Let's solve some example. I think that then this will be very clear for everyone. I will take this example to explain it very clearly. To explain it, just take a snap from that problem and paste it at here. We have total 8 lengths of an array where 8 elements we have to divide this 8 elements array into two portions such that the parity sum of the first portion and the parity sum of the second portion will be same. At the first time, this is our first portion, and this is our second portion. This is our second portion. We will assume that in the first portion we will keep 1, and in the second portion we will keep 2, 4, 3, 2, 3, 5 and 4. What is the summation of the first pair portion? This is 1, and the summation of the second portion is 2 plus 4 plus 3 plus 2 plus 3 plus 5 plus 4. That is 23. That is 23. What is the number? What is the parity of this first portion summation? That is odd. And what is the parity of the second portion? That is also odd. That means this will satisfy our condition. If this condition is satisfied, we will print yes, otherwise we will print no. This is the main requirement of our problem, or main graphic view of our problem. Let's solve another example. Let's solve another example. That is 4 and 7. Is it recorded? Yes, that is 4 and 7. In this example, we are clearly seen at here that if the first number of this element 4 we will keep is either in first portion or either in second portion, we have to keep the second element, that means 7, in the second portion or first portion. Both in that both case their numbers or their parity, both numbers parity is not same. Both numbers parity is not same. This is even and this is odd. So in this case, in our both portion we have to we can see this portion, this situation. First portion's parity sum is summation's parity is even, and second portion's parity summation's parity is odd, or first portion's parity summation of the parity is odd, or in the second portion this is odd. So here we cannot never created this kind of situation. So in this case our problem's answer is no. And we will solve another two example, then we will start the discussion of the main problem. 3, 9 and 8. 3, 9 and 8. Here this is our first portion and this is our second portion. At the first time we will keep only 3 at here, and 9 and 8 at this second portion. What is the parity of the summation of the first portion? That is 3. And what is the summation at here? This is 9 plus 8, 17. This is 17. This is also odd. This is 17 and this is also odd. That means this is odd, first portion parity is odd, second portion parity is odd. That means this satisfy our condition, both side parity is same. So here our answer is yes. Let's take another example. 5, 4, 3, 2, 1. 5, 4, 3, 2 and 1. This is our first portion and this is our second portion. At the first time we will keep 5 at here, and 4, 3, 2, 1 at the second portion. What is the summation of the second portion? This is 10. This is 10 and this is 5. This is odd and this is even. So this condition is not satisfying. So another element we will pick from here and put at here. 5 and 4. 5 and so the summation of the 5 and 4 is 9, that is odd, and 1 to 3 summation is 6, that is even. So still our condition is unsatisfied. We'll also pick 3 and put it at here. What is the summation of this parity? What is the parity of this first portion? 4 plus 5 plus 4, 9. 5 plus 4, 9 plus 3, 12. This is even. This is the parity is still even at here, and the parity of the second portion is 3. That means odd. So this condition is still not satisfied, and we will pick 2 from here and put it at here. What is the summation? 5 plus 4 plus 3 plus 2, that is 14. This is still even and this is odd. That means our condition is not satisfied here. The parity of the first portion and the parity of the second portion is not equal. So here our answer will be no. This is the main graphic view of our problem. This solution is very straightforward. At the first time we'll pick the first portion as the first element, and second portion as the summation of I is equal to 2 to n of array A, and we will running this operation, pick element from the second portion and put it at the first portion continuously until the condition is not satisfied. That means at the first time n minus 1th element is picked from here and put it at here. On the next step, n minus 2th element is picked from here and put it at here. Check these check both of their parity, this is same or not. If not same, we'll continue this process. And at the final state, when we will start, when the second portion has only one number, then we will start. Then we will check that the summation of the second portion, let's guess that variable is sum, that is greater than 0 or not, and sum of first portion parity is equal to the sum of the second portion parity of the second portion is equal or not. If this condition is satisfied, our answer will be yes. Otherwise, always our answer is no. So let's jump to the solution. Here we pick this first element as the first portion of our divided array, and take the let's all the elements summation from second index to the last index, and put it for the second portion. Now check that both of their parity is same or not. If already both of their parity is same, no need to no need to go forward for our calculation. We'll just print the yes. Now our calculation is mainly start. From which element we will pick from the second portion and put it into the first portion, that is the index 1 or the second element. So this will continue until this value is not cross the limit, and the parity of the both portion is equal or not. What the changes we will bring at here, we will put one element, ith element from the second portion, and put it in the first portion, and every time we will update the index I. And finally, if the second portion has such element or not, if the second portion have at least one element, that means sum of the second portion is greater than 0, and the parity of the second portion is equal to the parity of the first portion, then our answer is yes, otherwise our answer is no. Let's try to discuss about the second problem of the contest. What is the main graphic view at here? Here they give us a number. X. Here we have to perform the k rounding operation at here. What is k rounding operation at here? And in this value of the x, the digit count is started from the right to left. It started from 0, 1, 2, 3, 4, and so on. It started from right of the index 0 to the left, right to left. And the kth portion is such kind of operation that if we randomly pick a index k, then we have to check that at the k minus 1th index, the value is greater than or is equal to 5 or not. If this, suppose we have initially we have a value at here, this x, then this value will be increased by 1. This operation we can perform any number of time, but what is our main goal? Our main goal is to make the value of x as maximum as possible. And what if the digit is 9, as this is a digit string, then this will become 10. If the initial length of that string is m, then it will be m plus 1. This is the main graphic view of our operation, kth rounding operation. With this kth rounding operation, our value of the x will be as maximum as possible. What if the first index of this number is greater than or is equal to 5? In that case, we will add 1 at the first time and set all the n length digit. Suppose that the length of the digit x is n, then nth 0 will be set at here. And in this operation, if we pick an index k and this is satisfied for k minus 1, then from k plus 1 to n, all the digits will be set 0 at here. This situation they try to represent that in this way, that the value or the indexes that is smaller than k, we will set all of them is 0. After all the digits whose position is less than k, we replaced with 0. Why we will replace it from the right? At the first step we will discuss that our indexing is started from right to left. So if we pick k as 3, then all the small elements or all the small index than k will be situated at the right, not left. This is the main funda of this problem. So solution is very straightforward. As we have to set all the element from k plus 1 to n, we do not need to calculate the operation much more and more time, because the result will not be changes. And another observation have to consider at here, in our decimal number system, our number is distributed as this way, 10 to the power 2 and 10 to the power I. Now if we change some digit at here, at what position digit we have to change? If we change the digit from the leftmost side, then this will increase the value at a little rate, or some limited rate. But if we change the number from the leftmost position or the leftmost digit, then our number will be increased more and more when we change the digit only from the left. So we have to choose the leftmost position k, where this condition is satisfied, this digit is satisfied, then have to set all the element from k plus 1 to n at 0. Then set all the element of the k plus 1 to n as 0, and finally print that answer. We do not need to take another storage and keep them at keep that updated number from here. We can just change it from x, the number they give us to us. So let's solve an example. 41, 98, 60. 41, 98 and 60. 41, 98 and 60. Let's start the calculation. If we pick 0, then we can pick this value as the k, then we can make it 1, perspective of 6. As when we pick this element, when we will pick this element as the k, then we can make it 7, perspective to the 8. So then this will be 0. When we pick this element as the k, then we can make it 9, perspective to this 9 value, but when we will keep this element as the k, we cannot increase it. Though this k index is greater than or is equal to 5, but k minus 1's index, this is not greater than or is equal to 1. This is not greater than or is equal to 1. I will say this calculation to make it simply from left to right. To understand the main graphic view of this problem. But in this actual case, reality said that our counting start from right to left. 41, 98, 60. 41, 98 and 60. So if we pick our calculation 0, 1, 2, 3, 4, 5, 4 and 5. So where the k minus, what is the value we will consider as k minus 1? The rightmost element. The recent rightmost element we will consider as the k minus 1th element. So if we will pick 6 as the k, then we cannot increase it because 0 is not greater than or is equal to 5. But if we pick 8 as the k, then we can increase it 9 according to the perspective of 6, because this is greater than or is equal to 5. Then set all the element 0 at here, from right to left as the 0 at here. Then we will pick this index. Here we can increase it, yes, because this is 9. So we will set 10 at here. And all the remaining index from right, that k plus 1 to rightmost as 0. When we will pick 1 as the k, value of the k, then we can increase it by 1 according to the perspective of 9, so then this will be 2 and all the remaining element will be 0. So finally, we will discuss before that we have to choose the leftmost number or leftmost digit to maximize our number. So we will pick this 1 as the k and increase it 2 and set all the element from 9 to 0 as the 0, 3 to as the set as the 0, and we will get the number 42, 0, 0, 0 and 0. The number we get this is 4240. When is we see, if we see that the result 4240, this is the maximum possible number at here. We cannot increase more number, we cannot increase or maximize the number x more than this 42 into 10 to the power 3, 42 to 10 to the power 3. So this is our main requirement of this problem. We will solve another example with this procedure, and then we'll try to discuss about the problem 913. We pick another example. This is 913. If we pick, and they are number from 0, 1 and 2. At the first time, if we pick this element as the k, we cannot increase it as plus 1 because k minus 1 or recent rightmost element is not greater than or is equal to 5. If we will pick 9 at here, 9 as the kth index, then what we can do, then it has no left. So assume that 1 as the leftmost index and set all the element 0 at here. This is the maximum most element we will get. This is the maximum most element we can get at here. This is the maximum most element. And let's pick another example. This is 6947. 6947. This is the mainly sister test case of that test cases. When we will pick 4, we can increase it as 5. We can increase it at 5 and set this 7 as 0, 9, 0 and 16. This is our first probability. If we will pick this element as the if we pick this element as the k and check that 4 is greater than or is equal to 5 or not, definitely not. So we will check for this element 0. If we pick 0 as the k, then we can increase it 1 perspective to the value 9 at here. Then our value will be 61950. This is our second probability. We will see that our leftmost element, that is 6, greater than or is equal to 5. That is greater than or is equal to 5. But does it has some left element? No, it has no left element. So we will consider 1 as the leftmost element and set all of them as 0. Set all of them as 0. Set all of them as 0. Now what is our value of x? 150. 150. So our solution is it recorded? Yes. So our solution is very straightforward. We will start our calculation from the n minus 1th index and turn it to the 1th index, and every time we will check that our ith digit is greater than or is equal to 5 or not. and every time if this condition is satisfied, then we will increase our value of a minus 1 as plus plus. And in this case, what happened for the digit 9? Because we know that as a character index we cannot pick two character as the same index, so this 9 will be converted then as this ASCII value. Then this will give definitely more element. This will be give definitely more lexicographically larger value than 9. This will give definitely more larger value than 9. So we can continue our calculation. What the main duty at here? We'll pick the leftmost index. We will pick the leftmost index at here. We'll pick the leftmost index at here. Then set all the element. Then set all the element from len to n as 0 at here. Here we also have to check another situation, that is our first element of the digit or the first digit of the number is greater than or is equal to 5 or not. If this, then we will pick 1 and all the number of length n as 0 at here and print that number. So let's jump to the solution. This is our implementation of this problem. At the first time we will try to check that this is base case or not. If we don't want to keep this calculation, then we can skip it. Our len of the value is n, and we'll have to pick the leftmost position of the len, where the present digit is greater than or is equal to 5. If this situation is happened, we will increase the I minus 1th value. Why? Because the ith element we will calculate as the k minus 1th index. Our kth index is I minus 1th value. So we will increase the value of I minus 1th index of the k of the our main string a, and pick the length or pick the position of the indexes at here. Now what we have to do, we have to check the leftmost element or the first digit of the number is greater than or is equal to 5 or not. If this happened, then our len will be 0, started from 0. That means our whole string became 0 and added 1 at the leftmost position at here. Then if set all the element from len to n or k plus 1 to n as 0. Set all the element as k plus 1 to n as 0. We do not need to calculate this calculation more and more time, because after every calculation our all rightmost element will be 0. So we will find the sweetermost position and change all the element from k plus 1th index to n as 0. And if the len is 0, then we will just put 1 or inserted 1 at the leftmost position of that string and printed the total string as setted all of them as 0 and setted all of them as 0. If this is not, we'll just print the number we'll get after our calculation. This is our main implementation of our problem. Now let's come to discuss about the problem C, assembly via minimums. What is the main requirement of this problem, or what is the main graphic view of this problem? Is it recorded? Yes. The main graphic view of this problem is some person X has an array A of length n. He is very bored with this array. Then he will pick every two possible indexes I and j and put the minimum element of ai and aj. Put the minimum element of ai and aj. Put the minimum element of ai and aj at here. Put the minimum element of ai and aj at here. Then this is collected in element he is stored in another array b, whose length is m. Here m is n into n minus 1. Here m is equal to n into n minus 1 divided by 2. He shuffled this array p. He shuffled this array p. He shuffled this array b. Now he forget the original array a. Now he forget the original array a. We have to help him that what was the actual array a from which array he convert and get the array b at here. Which array he will convert and get the present array b at here. Here answer is always possible. We do not need to think that the answer is possible or not. Here answer is always possible. Let's solve an example. This is 753533. 7 5 3 5 3 and 3. 7 5 3 5 3 and 3. 7 5 3 5 3 and 3. Very good. Now what was the actual array he can get at here? The actual length of this array is 4. Then he have to pick 4 indexes element. We have 3 elements at here which is less than or equal to n. So put this 3 as the first index. Put this 3 in the first index. We have 2 element 5 which is smaller than or equal to 5. So put this element at here. And we have only one element 7 which has here we have one element 7 where a element that is greater than 7. That means we will put 7 at here. And here we can pick any large indexes or any large element as 12. If we want to make this array to our present array b, we can make it. Why? We will get 3 by comparing with this 3. By comparing with this, we can get also another 3. We can get also another 3 from here. We will get another 3. We will get another 3 from here. We will get 1 5 from here and get another 5 from here. We can get 7 from here. We can get 7 from here. If we compare this array with the initial array b, then we as this array is shuffled, so we this is not guaranteed that we will get always the actual array of b after calculation. So we will just count the every number that is present in both array. Here we have 3 3, we have 3 3, we have 2 5, we have 2 5, and we have 1 7 and we have 1 7. So this is our original array a. This is our main requirement or main graphic view of this problem. Now as our answer is always possible and the array element b is shuffled, that means we have to consider the count of every number, countation of every number. So we have to pick we have to create a key value pair data structure as map where we will count all the elements, where we will count all element of b, where we will count all, here we will count all the element, here we will count all the element of b. Then what we have to do, sort them. Sort b. Why we will sort b? Because as answer is always possible, if guess that here is an ith element when we will set a element E at here, then what the elements or what the sub-arrays element we will compare with this element A. This is from I plus 1 to n index, or that means for every number which is seated at position I, we will compare another n minus ith number from the right side of that indexes. So as the minimum value need to get more maximum value than this, that means the minimum possible number min 1, consider it as min 1, set it as the left index, then minimum possible number 2, set it as the second index, and so on. Why will set? Because the more maximum number we will help him to get more maximum number, as answer is always possible. So minimum 1 number will always get his suitable number of sub-array, suitable number of elements to compare with him. We do not need to think about that when answer is not possible. Answer is always possible, and this is also same for min to end, so on. And what we will do, we will set when the element over the ranges, when the element cross the number of ranges. Suppose here we will set 1 0, then we will get 3 number of element to compare with this, but we have to get 5 0 after the calculation of the array B. Then we will set another 0 at here, then he will also get these 2 element, and we will set that elements we will set that element repeatedly whenever our situation is valid or not. That means let's solve an example. We'll pick this element. We'll pick this example. Here, what is the computation of our array? This is 0. In for the map data structure or hash map data structure in Java, the number will always be stored as the sorted number. But if you use another key value pair data structure, you have to ensure that you will start the number computation from the minimum 1 number or from the ascending order sorted array. So how many 0 we have? 1 2 3 4 and 5. Total 5 number of 0 at here. How many minus 2 at here? We have total 1 2 3 4. Total 4 number of minus 2 at here. How many 3 at here? Only 1. How many elements we will set? 5 elements. So when we will set the minimum possible number minus 2 at the first indexes, then with how many number this will compare? First position. So this will compare with 5 minus 1 with 4 elements. Our main requirement is 4. So we can set minus 2 at here. This will compare all the 4 elements that is greater than or equal to minus 2. Then what is our next element? That is 0. Then if we will set 0 at here, with how many number this will compare? 5 minus 2. With 3 number this will compare. With 3 most possible number this will compare. This will from this to this and so on. But how many 0 we have? We have 5 0. So if we set another number of 0 at here, this will also get this 2 number. 5 minus 3 2. Then how many 0 we can compare at here? 3 plus 2 5, because this 0 will be compared with this remaining 3 numbers, and this 0 will be compared with this remaining 2 numbers. So total 5 number of 0 we will get. Then how many 3 we will have? We have only 1 3. That means this we will compare with this 5 minus 4 remaining 1 elements. How many 3 we will have? 1. So we can continue, and here we will set another large value which will be helped every number from n minus 1 position to first position. We'll set 12 at here, or any large number you can set at here. So have to observe that here the number we will set always in the range between 10 to the power 9. We cannot cross this range, and why we have to set the number in the range 10 to the power 9, because the number range at here is 10 to the power 9. Number range at here is 10 to the power 9. So why we will set the maximum possible value at here? We will set before that we want to create an ascending order sorted array, and this rightmost element will compare with other element. This is smaller than him, and help every element to get the minimum, get the number itself as the minimum one number. So the larger one number will set at here. This is our main solution approach. We will pick the number 7 5 3. We'll pick another example, 7 5 3 5 3 3 5 3 and 3. How many element countation we will have? We have total 3 number of 3s, we have total 2 number of 5, and we have 1 number of 7. How many elements we will have to set? We have to set 4 elements. We have to set 4 elements. If we set the minimum possible number 3 at here, how many elements he will get to compare with himself? 4 minus 1 3. Perfect. This 3 will be compared with this 3. This 3 number will be compared with this number 3. And if we set 5 at here, this will get this 2 number to compare with 5. We have 2 numbers, so we will complete this calculation. Then if we set 7 at here, then he get 1 number to compare with him, and this condition is satisfied. And here we will set another big number, 12, or any big number we will set at here, which is greater than or is equal to the all the leftmost number of the created array A. So the solution is very straightforward. We will, at the first time, we will pick an key value pair to store all the countation of the number B, and set all of them as the larger one value 10 to the power 9. Set all the value of the array A or final array as the large number of value, because the remaining rightmost element will be fulfilled with this larger value. The remaining rightmost element will be fulfilled with this rightmost element. So the value this is here is changes, is also changed from this indexes or these index elements, and the element this is not changes, we can keep it as it is. Then our indexes will start at from the 0, and for the first element this will compare with n minus 1th element with himself. So our subarray cover is n minus 1, and we will take another priority queue element. This priority queue element store this value of the element and countation number based on the element number and the count of that element. Here this is our element class, and with this help of comparable method we will store the value at here by comparing with the element at the first time. If both element is equal, then we will compare with the countation of that number. And we will create this key value pair, all the key value pair of map in this priority queue storage. Then until this priority queue is empty, we will remove element from here and put the element of the final array, put the element as the final array, indexes I. and update these indexes, and remove the count of the subarray. This will cover at here, and from this initial counting of the array, initial counting of that particular element, if this element is still present, if some countation is still present at here, this is like this 0, where the total number of countation is 5, but at the first countation, after first countation we will get only 3. We have also remaining 2 countation, so to complete this remaining 2 countation we have to add another 0. So for some cases we will have to add 5 zeros or 4 zeros, or for some other elements we have to perform this same number of operation. We will pick that new element number of that and that number countation in this priority queue, and finally we will subtract 1 from our subarray cover. Why will subtract 1? For the first element we have to compare with total n minus 1 element. For the second index we have to total n minus 2 index, and for the third index we have to compare with total n minus 3 element, and for the ith index we have to compare with a total n minus I index. So our value of the compared value will be decrease 1 by 1 after every iteration, decrease 1 by 1 after every iteration. So every time we will perform the minus operation at here, or decrease operation at here. So after all this countation we will print this final array at here. This is the third problem of our latest Codeforces contest. Now let's start to discuss about the problem D, strong vertices at here. What is the main graphic view of this problem? We have 2 array A and B of length n. Here we can construct a directed graph from these 2 array when this condition is satisfied. AU minus AP is greater than or is equal to BU minus BB at here. When this condition is satisfied, only that situation we can draw an edge between the vertices U and V. As this is directed graph, so if a path is allowed from U to V, then this is not granted that the path from V to U is always exist. This is always exist. So by following this situation we will build a graph. We will build a directed graph. Then we have to find the total number of strong vertices. Then we will have to find the total number of strong vertices. What is the condition of the strong vertices? A strong vertices is such kind of vertices from which vertices every other vertices will get an path. Suppose this vertices is B1. This vertices is B. This is strong vertices because other vertices 1, 2 and 3 is get a path from the vertices P. We will have to publish the total number of strong vertices at here, and these vertices will have to print the ascending order. At the first line we have to print the total number of strong vertices, and in the second line we have print the total m number of vertices as the ascending order. This is the main requirement of our problem. If we pick the first example, this is our builded graph from the given 2 array A and B. This is our builded graph from this 2 array A and B. And how many strong vertices here it has? The total number of strong vertices they present at here, this is 4. Why 4 is a strong vertices? Because 1, 2 and 3, both of them get a path from these vertices. So total number of vertices is 1, and the vertices are 4. And if we will pick this situation for the second example, our created vertices is, our created graph is as like as this way. Why? How many vertices this is strong at here? If we pick a 5, then all other vertices get a path. So one condition is 5. Here we just take a snap from here. Snap from here. How many strong vertices here we have? 5, because 5 is connected with 1, 3, 4 and 2. And 3 is also strong. Why? Because 3 is also connected with 1, 4, 2 and 5. Our second connected vertices is 3. And 2 is this is connected strongly. 3, this is connected because 3 and 5. We have only 2. We have only 2 vertices, 3 and 5. This is connected, or this we can consider as a strong vertices. This is our main requirement from this problem. So we do not need to build this graph. We do not need to put any calculation to build this graph. We will just have to consider with this the condition they will give. The condition they will give to us, this is, the mouse is flaked, sorry for that. This condition is AU minus AV is greater than or is equal to VU minus B of V. VU minus B of V. We'll just take an updated version of with this condition. AU minus BU is greater than or is equal to A of V minus V of V. Yeah, B minus V of V. So assume that first number is S1 and second number is S2. From this condition, we will minimize this situation as S1 is greater than or is equal to S2. Why will we can minimize this situation? Because this difference of every indexes AI minus B of I is stored, A of I minus B of I is stored in another array C of length n. From that array, we will consider this situation and count the number of vertices. For number of vertices, for every vertices I, suppose that I, how many vertices it can connect it with, as like as I plus 1, I plus 2 and all other remaining element, all other remaining vertices. We will count that these I vertices can connect it with how many vertices from him with other vertices. These vertices with counted with how many vertices, how many other vertices with this following condition. When we can satisfy, when we get or find any situation that how can we understand, or how can we understand that a vertices P is connected with all other remaining vertices n minus 1 with the maximum value, with the maximum value of C, with the maximum value of this C. Because a vertices must have to be if a vertices have to be a strong vertices, then it must have to it has some value of C of I, then it must have some value of C of I, which is AU minus VU, considered as AU minus VU is maximum value of C of I, maximum value of C will be greater than or is equal to remaining n minus 1th value of the stress. So we will have to count the maximum value of this C, and this is our model value. That means this value of C or the vertices which has this maximum value, this can connect it with all other remaining n minus 1 vertices, and we'll count this maximum number. We'll count this maximum number from all the number of this C from 1 to n. Here don't we need to check that our answer is never possible. Our answer is always possible. Only one vertices, at least one strong vertices is present at here, will be present at here. Only at least one strong vertices is present at here. So we will count the maximum value of this C, and the total number of strong vertices is the count of max element, count of that max element, count of that max element M, and indexes of that max element. So solution is very straightforward. Let's see an example. Before see the example, we'll after see the example, we'll try to calculate it. Just pick this example. Here, what is the value of this C, or the value of the array C will can make minus 1, minus 1, minus 1. This is the value of this C at here. What is the maximum value of this C? Minus 1. How many minus 1 we will have? 3. What is the vertices? 1, 2, 3, and so on. Let's solve another example. This is that means this will mention that 1 can connect it with all these vertices 2 and 3, 2 will connect it with all these vertices 3 and 1, and 3 will also connect it these vertices 1 and 3. Let's see an example. As our graph is built according to the perspective of this condition, S1 is greater than or is equal to S2. So we do not need to make another calculation. Minus 4, 0, 1, minus 2, and 1. What is the maximum value? 1. How many times this is presented here? 2. And which indexes they will this will present? 1, 2, 3, 4, and 5 at the 3 and 5th index. So 3 and 5 is our answer. So solution is very straightforward. Let's jump at the solution. At the first time we will create another array C of length n, which will carry out all this number ai and bi from 1 to n, and count the maximum element of the C, which is the ideal element or ideal vertices which can connect it with all other remaining vertices. Just count the maximum number of element at here, maximum number of element present at C, and find the indexes where the maximum element is present or not, or at which position I is equal to max or not. Just collect the indexes to another storage. At the final stage, just print the collected array and the size of that array. This is our implementation of the number 4 problem. I think this will be helpful for us. For any query, feel free to comment here.